What up, Internet? This is Chris coming at you from mathmeeting.com. And before you get started with this video, I just want to let you know that we do offer live tutoring from the comfort of your own computer, full detailed homework solutions for any math assignment, and there is a complete list of all the free math videos that I've made that you can watch. All of this is at mathmeeting.com. Once again, mathmeeting.com. In the meantime, I hope you enjoy this video and take care. Hey everybody, welcome to my video. I'm going to be discussing how to find the critical points of a function. And I wrote the definition for you in blue, and it says that there's a critical point at x equals c if the derivative is equal to 0 at that point, or if the derivative is undefined at that point. And also, c must be in the domain of the original function. And this is going to make a lot more sense once we get started with an example, so let's just get started right away. So here we have the function f of x equals 5 over x squared minus 4x squared. And to take the derivative of the function, you probably think that you have to use the quotient rule, but I'm going to do a little trick using algebra just so we avoid using the quotient rule. And instead of writing it as 5 over x squared minus 4x squared, I'm going to write it as 5 multiplied by x squared minus 4x, and instead of a positive 2 exponent, now it has to be a negative 2 exponent. A positive exponent in the denominator is a negative exponent in the numerator. So now instead of using the quotient rule, now we can just take the derivative using the chain rule. First, you want to take the negative 2 exponent to the front, multiply it by the 5. The parentheses stays the same. The negative 2 exponent is subtracted by 1, so it becomes negative 3. And finally, we multiply by the derivative of the inside of the parentheses. So the derivative of x squared is just 2x, and the derivative of negative 4x is just minus 4. Now we just need to simplify this doing some algebra. I'm going to multiply the negative 2 and then 5, and that becomes negative 10. That is being multiplied by the 2x minus 4. And instead of having a negative 3 exponent in the numerator, I'm going to write that as a positive 3 exponent in the denominator. So I'll rewrite that term, x squared minus 4x, with a positive 3 in the denominator. So let's find our critical points. If you remember from the definition, we have critical points when the derivative is equal to 0. And this derivative is going to be equal to 0 when the numerator is equal to 0. So we can solve this equation pretty easily. If we divide both sides by negative 10, we get 2x minus 4 is equal to 0. Now if we add 4 and then divide by 2, we get x is equal to positive 2. So x equals positive 2 is a possible, it's a candidate for one of our critical points. And if you remember from our definition, we also have critical points when the derivative is undefined. And the derivative is undefined when the denominator equals 0. So x squared minus 4x cubed is equal to 0. So now I'm going to cube root both sides, and the left side just becomes x squared minus 4x, and the cube root of 0 just equals 0. And now I'm going to factor out an x. And now if we set both terms equal to 0, we get x equals 0 and x equals 4. So now we have 3 possible critical points. So we have a possible critical point at x equals 2, and we have a possible critical point at x equals 0, and a possible critical point at x equals 4. And I'm going to write this down for you in purple on the bottom. We have possible critical points at x equals 0, x equals 2, and x equals 4. Remember, they're only critical points if they're in the domain of the original function. So let's plug them in to the original function just to make sure that they're really critical points. So first we'll plug in 0 for x, and then you get 0 squared minus 4 times 0 squared in the denominator, and you have a 5 in the numerator, and that is equal to 5 over 0. If you remember, you can never have a 0 in the domain of the function. So x equals 0 is not in the domain, therefore it cannot be a critical point. So I will cross it out because we cannot be a critical point. So now let's check out x equals 2. Let's plug in a 2 for our x, and we get 2 squared minus 4 times 2 all squared in our denominator, and we have a 5 in our numerator, and that is equal to 5 over 16. So now we do not have a 0 in our denominator, so x equals 2 is certainly in the domain of our original function, and it is certainly one of the critical points. And finally, let's test out x equals 4. If you plug 4 in for x, we get a 4 squared minus 4 times 4 all squared in the denominator, and we have a 5 in our numerator, and that is equal to 5 over 0. Once again, we can never have a 0 in our denominator, so therefore 4 is not in the domain of the original function, and therefore x equals 4 cannot be a critical number. So this function has one critical number at x equals 2. And critical numbers can be used to find relative minimums and relative maximums. Critical numbers can be also used to find whether a function is increasing or decreasing. I will be posting videos on those topics very shortly. So I hope this gave you a better understanding of how to find the critical numbers. If you need any extra help with live tutoring or homework solutions, please go to my website at mathmeaning.com. Once again, mathmeaning.com. I really hope you enjoyed this video, and take care.